We are moving into section G5, and we are still talking about rhombuses and rectangles and squares and determining whether a parallelogram is one. And so we have some theorems here talking about the properties that we talked about last time. This one says that if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. We talked about that last time. As soon as we know that the diagonals are perpendicular, we can say that this is a rhombus. Remember, a square is also a rhombus and a rectangle is also a rhombus. So this could also be part of a proof to show that we have rectangle or a square. Another theorem, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So this diagonal is bisecting the angles opposite side, so we are going to definitely have a rhombus. And again, we might have a square out of this because of the rhombus. And if the diagonals of a parallelogram are congruent, then the parallelogram is a rhombus. So if the measures of the parallelograms of the diagonals are congruent, then we know we have a rectangle, not a rhombus, but a rectangle. It's also going to be true of that rhombus. I'm sorry, not a rhombus, but a rectangle. So there's a look at that. Let's take a look at a couple of examples here. So let me pull out my examples. And let's say, can we show that that's a rhombus or a square? Doesn't mean, just because it looks like a rhombus doesn't mean that we have to prove it. So how do we know that this is a rhombus? Well, we talked just a second ago about the property right here that says if a diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. And that's what happens right here. We've got these bisected. So this has to be a rhombus. Over here, not only do we have perpendicular diagonals, which mean we have a rhombus, but we have congruent diagonals. So that means it's also a rectangle. A rectangle that's also a rhombus is called a square. So that's some more information we need to find out that that's a square. And last but not least, we're going to take a look at this shape and say for what value of x is this parallelogram a rhombus. And if that's a rhombus, these angles would be bisected, so I can simply set those equal to each other, and I can solve for x. So let's subtract 4x from both sides. Let's add 2. We get 2x equals 10. And finally, dividing by 2, x will be 5. The question was, what's the value of x? X would have to be 5. We could plug 5 back in here and find out that 28 degrees would be each of those angles. And there's a look at our lesson for this particular section.